General Principles for Material Selection and Corrosion Protection based on NORSOK M-001 Guidelines for Durable Materials and Effective Corrosion Defense. Overview and Philosophy of Material Selection. Material selection and corrosion protection are critical aspects of offshore and onshore engineering projects, ensuring safety, reliability, and cost-effectiveness throughout the life cycle of facilities. The NORSOK M-001 standard provides guidelines for selecting materials that can withstand harsh environmental conditions, including seawater exposure, high pressures, and varying temperatures. The philosophy emphasizes a holistic approach, considering operational conditions, maintenance strategies, and environmental impact. It advocates for selecting materials based on proven performance, compatibility with design requirements, and compliance with international standards. The goal is to minimize corrosion risks, reduce downtime, and optimize long-term integrity. This involves evaluating the entire system, including structural components, piping, and equipment, and applying preventive measures such as coatings, cathodic protection, and chemical treatments. By adopting this philosophy, engineers can ensure that materials are fit for purpose, cost-efficient, and sustainable, while meeting safety and regulatory requirements. Key criteria for material selection. Material selection requirements under NORSOK M-001 involve assessing mechanical properties, corrosion resistance, weldability, and availability. Materials must withstand operational stresses, including pressure, temperature fluctuations, and chemical exposure. Selection also considers fabrication processes, inspection feasibility, and repair strategies. For offshore structures, resistance to seawater-induced corrosion and fatigue is paramount. Materials should comply with recognized standards such as ASTM, ISO, and EN, ensuring global compatibility. Economic factors, including life cycle cost and ease of procurement, play a role alongside technical performance. Environmental considerations, such as minimizing ecological impact and supporting sustainability goals, are increasingly important. The process includes detailed documentation of material grades, specifications, and testing requirements to ensure traceability and quality assurance throughout the project lifecycle. Corrosivity assessment and protection strategies. Corrosivity evaluation involves analyzing environmental factors such as temperature, humidity, salinity, and chemical contaminants. Offshore environments present high corrosion risks due to continuous seawater exposure and oxygen availability. NORSOK M-001 recommends using predictive models and empirical data to classify corrosivity levels and select appropriate protection measures. Strategies include applying protective coatings, implementing cathodic protection systems, and using corrosion-resistant alloys. Internal corrosion in pipelines and closed compartments requires chemical treatment and monitoring. Corrosion protection plans should integrate inspection schedules, maintenance protocols, and contingency measures to address unexpected degradation. Advanced techniques like corrosion inhibitors and real-time monitoring sensors enhance reliability and reduce operational risks. By combining preventive and corrective measures, engineers can extend equipment life and ensure compliance with safety standards. External corrosion and splash zone solutions. External corrosion protection focuses on surfaces exposed to marine environments, including structural steel and pipelines. Coatings such as epoxy, polyurethane, and zinc-rich primers provide barriers against moisture and oxygen. The splash zone, located between high and low tide levels, is particularly aggressive due to constant wetting and drying cycles, mechanical impact from waves, and high oxygen content. Solutions include reinforced coatings, elastomeric wraps, and sacrificial anodes for cathodic protection. Regular inspection and maintenance are essential to detect coating failures and corrosion initiation. Advanced technologies like thermal spray aluminum, TSA, offer long-term protection in splash zones. Design considerations include accessibility for maintenance and compatibility with other protective systems. Implementing robust splash zone protection minimizes structural degradation and ensures operational safety. Use of coatings and cathodic protection principles. Coatings serve as the first line of defense against corrosion, providing a physical barrier between the material and its environment. Selection depends on factors such as substrate type, exposure conditions, and application method. Common coatings include epoxy, polyurethane, and thermal spray aluminum. Proper surface preparation and quality control during application are critical for performance. Cathodic protection complements coatings by using sacrificial anodes or impressed current systems to prevent electrochemical reactions that cause corrosion. Design involves calculating current requirements, selecting anode materials, and ensuring electrical continuity. Monitoring systems track protection levels and detect failures. Combining coatings with cathodic protection offers a comprehensive solution, reducing maintenance costs and extending asset life. These methods are widely used in offshore platforms, pipelines, and subsea equipment. Closed compartments, insulation, and atmospheric exposure. Closed compartments, such as ballast tanks and void spaces, pose unique corrosion challenges due to limited access and stagnant conditions. Protection strategies include applying robust coatings, using corrosion inhibitors, and implementing periodic inspection through remote monitoring. Insulation systems, while essential for thermal control, can trap moisture and promote corrosion under insulation, CUI. Selecting non-absorbent insulation materials and applying protective coatings beneath insulation mitigate this risk. Atmospheric exposure affects topside structures and equipment, requiring coatings resistant to UV radiation, temperature fluctuations, and pollutants. Regular maintenance and recoating schedules ensure continued protection. These considerations demand integrated design and operational practices to prevent localized corrosion and maintain structural integrity. Galvanic corrosion and weld overlay techniques. Galvanic corrosion occurs when dissimilar metals are electrically connected in a corrosive environment, causing the more anodic material to corrode. Prevention strategies include selecting compatible materials, using insulating gaskets, and applying coatings to isolate metals. Preferential weld corrosion is another concern, where weld areas corrode faster due to metallurgical differences and residual stresses. Solutions include using corrosion-resistant filler materials, applying weld overlays, and performing post-weld heat treatments. Hard-facing techniques enhance wear resistance in critical areas, extending component life. Proper design, material selection, and inspection protocols are essential to minimize these risks and ensure long-term reliability of welded structures. Chemical treatment and life cycle corrosion management. Chemical treatment involves using corrosion inhibitors, biocides, and oxygen scavengers to control internal corrosion in pipelines and process systems. Selection depends on fluid composition, temperature, and flow conditions. Continuous monitoring ensures effectiveness and prevents secondary issues such as scaling or microbiological growth. Corrosion management encompasses planning, implementation, and review of protective measures throughout the asset lifecycle. It includes risk assessments, inspection programs, data analysis, and corrective actions. Digital tools and predictive analytics enhance decision-making and optimize maintenance schedules. A proactive corrosion management strategy reduces operational risks, improves safety, and minimizes costs, aligning with regulatory and sustainability objectives. Key takeaways and best practices. Effective material selection and corrosion protection require a comprehensive approach that integrates design, operational, and maintenance considerations. Following NORSOK M-001 guidelines ensures compliance with industry standards and enhances asset reliability. Best practices include selecting proven materials, applying robust coatings, implementing cathodic protection, and adopting proactive corrosion management strategies. Continuous monitoring and timely maintenance are essential to mitigate risks and extend service life. Collaboration among engineers, operators, and inspectors fosters informed decisions and sustainable operations. By adhering to these principles, organizations can achieve safety, efficiency, and environmental stewardship in challenging industrial environments.